Martha's Vineyard, a picturesque island a short 7 miles off the coast of Massachusetts, is a popular vacation destination. The island is also home to Martha's Vineyard Airport. Located in the middle of the island, it is the only airport served by commercial airlines. The airport is also used by a significant number of general aviation aircraft, with a high number flying in during the summer months. Over the years, as required by the FAA, the airport has conducted fire training exercises releasing AFFF firefighting foams in an area adjacent to the runway. Beginning in November 2018, as awareness and concern about PFAS and AFFF were increasing, the Martha's Vineyard Airport proactively identified an approach to contain AFFF testing solutions, and current FAA testing procedures do not require the discharge of AFFF. As a result of the AFFF releases, the groundwater has been impacted with PFAS contaminants that are now being proactively treated by the airport. Tetra Tech, a global environmental consultant firm, has worked with Martha's Vineyard Airport over the years.
So around 2018, we approached the Martha's Vineyard Airport Commission about potential concerns with firefighting foams and asked them if they'd like to explore this potential concern. We did some initial evaluation of the site and identified some elevated concentrations of PFAS. And that was really what prompted us to continue to advance this program.
Tasked with evaluating available options to address the PFAS impacts, the team developed a remedial design incorporating permeable reactive barriers emplaced in situ using PlumeStop colloidal activated carbon amendments.
So we chose PlumeStop for this pilot test, but we did look at other remedial programs or possibilities, including pump and treat. The reason we moved in this direction is we wanted some more certainty in the fact that we were going to be targeting the area of contamination and be able to address it. And we felt PlumeStop gave us the best opportunity to do that.
We're finding at sites like this, it's going to be, a very widespread problem. You've had a history where PFAS was used as part of training, and so it's only really a matter of time and not a surprise that it's found its way into groundwater. We're going to keep it from going off-site and protecting any of these receptors that are down gradient.
The PFAS plume extends out beyond the airport property into surrounding residential properties, where residents rely on private wells for their water resources. Prior to the final remedial design, Tetra Tech worked with Regenesis to effectively characterize the site. Flux tracers were utilized to identify high flux zones and allowed the team to target these zones in the pilot test plan.
We find the use of the flux tracer is really critical to the success of any remediation that we employ, and is able to be used to look at the groundwater flow, but we're also able to identify the vertical delineation. So we look at groundwater flow plus PFAS, and that allows us to ensure that our design is appropriate, again, to meet expectations.
Site characterization is very important. You don't want to be surprised by anything whenever you come out here. You want to make sure that your cores that we take whenever we arrive on site match the cores that the clients gave us during the design process. Make sure everything's copacetic.
PlumeStop is designed to rapidly remove PFAS contaminants. Composed of micron-sized particles of activated carbon suspended in water using organic polymer dispersion chemistry, once in the subsurface, PlumeStop behaves as a colloidal biomatrix, binding to the aquifer matrix, rapidly removing PFAS from groundwater.
So one of the reasons we selected PlumeStop was because it didn't have that ongoing operation and maintenance cost. It goes in the ground and it's doing its job. And that's a real selling point. We talked earlier about the cost of disposing of materials from an island. That doesn't happen with PlumeStop. It goes in the ground and it will retain the PFAS for decades.
We've seen the environmental community respond quite well to the PlumeStop. We have a lot of projects in the ground. We've got over 30 at this point, and we've got tremendous results as we go, and people are really taking note to that, and it's ramping up. As more PFAS jobs come in, we anticipate a very positive response.
In less than 4 months, the installed PlumeStop barrier had shown rapid reductions in groundwater PFAS concentrations, substantially reducing mass flux immediately down gradient, with reductions seen further beyond the barrier. PFAS concentrations are expected to decrease at a further distance in the plume as the clean water front advances down gradient from the barrier. The current pilot barrier is designed to immobilize PFAS in the plume's core for 15 years or longer, minimizing plume migration away from the site. The remedy mitigates the problem cost-effectively and sustainably, while eliminating harmful greenhouse gas emissions and the need to transport hazardous PFAS waste materials off the island.
I've been very impressed with the Regenesis team. The important thing about this project, especially a new contaminant issue like PFAS, is having someone with experience. And for a contaminant class that's only been considered a problem for 4 or 5 years, Regenesis had the experience that I felt comfortable moving forward with them.
For more information about how PlumeStop is sustainably and reliably eliminating the risk of PFAS on industrial and airport sites globally, go to www.pfastreatment.org.